Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna take a look at the one node that we haven't used. Actually, it's called extrude edge. Yeah, we're just gonna get started. It's just my exploration of this node. I haven't used it for. I just used it yesterday. Actually, I just tested it out, but I want to do a little bit of exploration. It's quite an interesting node in itself. So if we check extrude, Sverchok has these extrude separate faces that work on a polygon. It's gonna do the extrusion and gonna separate the face. And there's this extrude edges, and this is the one that's particularly interesting. I just explored it the other day, and I actually write down this question about extrude edge, and then I actually want to make something that looks like a kind of leaf. So if you have like you have a, if you are doing it manually, and see, I'm in Blender, we can easily extrude the points, and we can also easily extrude edges like that. This is actually kind of thing that I want to do using Sverchok, just extruding to the left and extruding to the right. It's a two-step process. I want to do it one time. So anyway, let's have a look. View a draw, plug that in. So, and I'm gonna use line in this case. By default, line actually goes in the X direction. Let's make the line goes up. So we use a rewire, vector rewire, X to Z. Now we have line that goes up like that. I'm gonna plug this in and plug that in. Okay, we still have just line. That's because we need to provide matrices. So like if you're doing the extrude, where at which direction you want it to go, right? Matrix in, plug that in, and look, we need to provide some kind of directions here. So vector in, let me try this. Okay, that's I'm using random vector. Random vector give us like a random directions, but we're not gonna do that. Let's use a proper one like vector in, and let's say we extrude it in the X directions, X00. So that's pretty obvious. And then if we do it in X and Y, we get something that's diagonal. Just Y, of course, give you Y axis. And if we are doing it in the Z axis, of course, it's extruding up. It's a bit weird, but you can do that as well. So that's pretty obvious. And apparently we can also kind of do it in a rotation. I'll try the rotations. Let's say we want to rotate it in the Z as axis. So 001 with the angle. Let's see if this is actually working properly. Apparently it doesn't quite work that way. Okay, that's the first. I'm gonna show you another way to do that. You can also have scale and rotations. Before I go to scale and rotations, I'm gonna try using random vector here on the X. If we use random number, what we're gonna get? Apparently we have this. So this is quite interesting, right? How many vertices? Okay, 10. So the number of vertices and the number of points will be our key here. The number of points should match these original points that being extruded. So by doing that, we have this kind of a structure. Very interesting. It's a normally when you extrude something you don't get this kind of randomization very easily. So that's one kind of like one little trick. Maybe I'll bake it out anyway. And then we can of course use noise and things like that. Or let's see, the easiest one also vector fractal. Just plug in this guy, actually looking for vertices, so vector in vertices, just use the line. I guess that will work. So that's fractal. Can play around with this parameters. I can bake it out. So this is a second kind of extrusion. I don't think we can extrude it multiple times or extrude with a subdivision yet, but this is I guess it's still an interesting start. In here I actually have a question, and then I kind of doing a weird rotation here. So I'm using range float, and then there's a rotation, plug into the least joint, and then okay, I'll show you what I was doing there. Basically, we have this extrusion in the x-axis, right? And I was thinking, okay, maybe I can use rotation node. And rotation node is, it allows you to do rotations in axis, Euler, or quaternion. Let's try Euler, is easy one. And we can kind of doing the rotations in the z-axis. So this is what I did. So because we have one, we just have this one value, and then we rotate that using the z-axis. That's why we have this. So this is doing it this way. We have control for our, let's say if you want to make like a leaves and you want to draw it in one direction and in another directions, you want to do this and you want to do the other side. So that might work. Let's see if we use a formula. I don't know yet if this is gonna work. 0 and 180. This apparently this is probably not gonna work that way. So the way it might work is to use these matrices, but here I'm doing this something. I get to this this kind of like a twisting, extrude and twist. How did I get to that? So basically I'm using range float. So by trial and error I actually get to design this twist. Location 23 goes into the matrix, expecting one matrices. So I just use least join here. Mix and wrap. I think I did it like that. In here, join list to Euler 46. Okay, number of vertices this should match. So that's controlling that rotation. Location, scale, rotation, join list level. So maybe there's some kind of maybe there's something I forgot here. Maybe the count here. Let me check the number. Okay, Sverchok just crashes. Blender, I'll restart Blender real quick. two accidental things being created. Okay, let's cut that stethoscope and check the data. Okay, 0 to 10. Okay, maybe I need to make it 0 to 360 and plug that in. There we go. That's the spiraling thing that I was talking about. Quite unusual. You can do like more spiral, of course. So that's another design. Remember, this is just extrusion, but extrusion, we are controlling the new points, and that's why you get something like this. If we are actually, instead of using line, if you are using something else like a circle, we're gonna get something a little bit more interesting. So circle, edges, and viewer draw. And then how do we want to push the circle points? For example, in this case, if we push it up, we're gonna extrude up. So this is something that's not quite easy to understand. You know, if we push it up, okay, we get that. But if we push it in the X direction, we get that. What if we want to push it in all directions? Now, apparently, the easiest way is to just plug in the vertices of this guy to that guy. Yeah, that's a kind of like pushing it outward in all directions. Not easy to do. Like sometimes it's hard to think from X, Y, Z, and suddenly you want to use like a polar coordinates, like a circular kind of axis. But anyway, it seems to work like this, and then if I'm not wrong, you can just also use randomized input vertices and get some variation. Yeah, so that's quite interesting. I don't know if we can extrude this twice by using the same format. Maybe you can. I haven't tried this. Matrices. And then just extrude it again. Okay, so apparently it does sort of work. There you go. That's by using like a piggyback, we are extruding this guy twice, and that seems to be a good. Okay, that's another interesting surprise, and you can also use the scale here. So if we use like a random, actually before we use random, let's use random vector, plug into the scale, we're gonna get some kind of random extrusion. So again, this is another kind of surprise. Maybe this is too random. I'm not gonna do too much randomness. Maybe use a fractal or random number generator for the scaling. Okay, this is float goes into the vector. It's not gonna work. We need the vector in. So that might give us something interesting also. Okay, so what's going on there? Maybe we don't have enough number. — 48. Funny thing, we need a 48 of this, and then apparently we are also kind of extruding the previous circle. So this is a that's interesting. I didn't expect that. I expected, okay, it's got extruded and then it's kind of joining it. this guy 24, but we kind of that's a bit strange. 24, and okay, this we need to fix this first. Vertices, edges. Let's cut this and then do a single extrusion first. Okay, we get that. That's that I can understand. Okay, this is the first result. Gonna bake it. So we have this, and then the result is this guy. I don't know. Maybe we need to use some kind of mesh joint or the new edges. Oh yeah, I haven't talked about this. New vertices, new edges, and new faces. If you want to do like an extrusion, of course, the second time we need to extrude only on the outer kind of circle, not the inside as well. Otherwise, we're gonna do like a 2 times extrusion. What I mean is, why I made a mistake earlier. It's like if we just piggyback it and then extrude it up, you will see what's going on. It's actually generating this object, which is actually can be interesting, but it's not really extruding it properly. It's just extruding the face. Yeah, probably a better way is not to use extrude edge, but extrude separate faces. But extrude separate faces, of course, generate like a separate extrusion. I'll show you real quick. There you go. This is a extrude separate. Well, this can be useful, but for some other time. Now with extrude edge, we want to really just extrude the new vertices, I guess. So if we want to piggyback this guy, maybe we just use the new vertices and the edges with the matrices. Maybe like that. I think I plug in the wrong thing. So vertices and new edges only, and just extrude up. Okay, this is more correct. This is what I was trying to do. If we bake it, we have this. So, but this is like 2 different things. So we need to kind of baking it. So that's interesting because that's like a 2 different process. So I think we can just combine the 2. Mesh join, or maybe list join and then mesh join. Yeah, extrusion is not like something that's too straightforward in Sverchok, but you can piggyback it this way. So this is I'm gonna use different color, red and then green and then blue. This is I'm gonna do the same thing. Okay, vertices and then the new edges, and then do another extrusion. This time we're gonna do it outward. result there. There's a funky thing going on there. 72. Maybe just new vertices. Okay, that's interesting. I didn't expect that, but this is maybe I need to do that as well. No. This goes in there. So this is matrices 28, this is matrices 1. I have a feeling that the vertices here still have the normal from this guy, so that's why we have this kind of like a flowery kind of result. Very interesting. So basically this is our look at extrude edges. And we are using line and also we are using circle. They both give kind of a interesting result. Didn't expect all of those. Probably I will do a little bit more explorations on this. Let's see, 3D display, shading, matte cap. Yeah, I'm just gonna do like a screenshot for this video. So the weird thing you can do with a extrude edge. There you go. This is just a quick explorations. I'm gonna give you this note 3. You can give it a try yourself, see what you can come up with. Getting familiarize yourself with the extrude edge, and really the original idea is I just want to make like some kind of leaves, so we can easily make like the fern plants, just like in the previous live noding. But yeah, so we end up with this. If you have any questions, suggestions, just let me know down below, and I'll see you in the next video. Thank you.